Hi, you are watching this video today to hopefully move up a level on your 3.3 standards-based grade. I can solve special systems of linear equations. So far this unit, you've talked about systems of linear equations, which are two or more equations that have the same solution. That solution is an ordered pair that would solve both or all of the equations in the system. We have learned how to solve systems of linear equations through graphing and elimination and substitution. And in all three of those methods, so far, we have gotten one solution. But today we're going to focus more so on when you have a special system, which are occasions where there's not one solution. There is either no solution or there is an infinite number of solutions. So, really quickly looking at the three methods, you can see graphically that there is one solution if those two equations in the system cross, and that coordinate on where they cross will be a solution. There is a no solution if when you graph them, they never cross, which means they are parallel. And there is an infinite number of solutions if the two equations end up being the same line. So they're right on top of each other, which means they cross each other at an infinite number of spots on the line. So graphing, we can easily see it. I'm also going to show you algebraically how we can look at substitution and elimination to prove that it's either a one solution, no solution, or infinite number of solutions. So one solution, we know that if we are solving one solution, we can substitute in that 3x plus 4 in for y. So I would have 3x plus 4 equals 1/2 x minus 1. And this is the one you're most familiar with. So when I subtract 1/2 x, I get 5/2 if I put it into an improper fraction, or 2.5 if you did it that way. And then I subtract 4. So I end up with 5/2 x equals -5. And then I multiply by the reciprocal to get x by itself. So when I do that math there, I get x equals -2, which is half of my solution. And then I can plug -2 into one of my equations. 1/2 times -2 is -1. So -1 minus 1 is -2. And of course, we can always double check to make sure that -2 is a solution to the other equation. We have -6 plus 4 is -2. Yep, that checks out. So substitution. By elimination, we can check if it's one solution by eliminating one of the variables. And when I add what's left, I get 6x equals 24. So x equals 4. And then I plug that back in. So 5 times 4 plus 6y equals 50. And I subtract that 20. I get 6y equals 30, so y is equal to 5. And of course, it's always a good idea to double check. So I have 4 minus 6 times 5 equals -26. And yes, that checks out. So I have a solution. Today, we're going to talk about, well, if it has a no solution and I want to solve that by substitution, I'm going to do the same thing I just did. I'm going to substitute this in. So I have 3x plus 3 equals 3x minus 1. Oh, really quickly. We could, if they're both in slope-intercept form, we can see that they're parallel just based on what we know about parallel lines. They have the same slope. So that should be a giveaway if they're both in slope-intercept form. But if I wanted to do it by substitution, I could kind of substitute in here. And when I solve, well, this cancels, so I get 0 plus 3 equals negative 1. And 3 equals negative 1. That is a false statement. Ooh, that's an S. So if you end up with a false statement, you have a no solution. That is true if you do it by elimination as well. So first thing, if I want to do this by elimination, I have to put this into standard form. So I have 2/3 x plus y equals 6. But I have to multiply this by negative 3 so that I both have it in standard form, so it is an integer, not a fraction. And I want to multiply it by a negative so that I have something that I can eliminate. So I end up with a negative 2x minus 3y equals negative 18. When I multiply that out, and then I'm just going to slide this down here, 2x plus 3y equals 6. And then I'm ready to eliminate. So when I'm ready to eliminate, I see that these two eliminate and these two eliminate. So I end up with nothing on that side. And negative 18 plus 6 is negative 12. Again, this is not a true statement. So if it is a false statement, we know we have a no solution. If we're looking at a special system that has an infinite number of solutions, you can probably guess that we're going to end up with a true statement at the end, but I'm going to show you an example here. So once again, I'm going to substitute in. This one is solved for y, so I'm going to substitute into the y here. So I have negative 2x plus, and I'm going to substitute in for my y, 2x plus 1 equals that 1. Well, right here, I can see that 2x minus 2x, if I combine like terms, those cancel each other out, plus 1. So I have 1 plus 1. 1 equals 1. So that is a true statement. So we have an infinite number of solutions. Now, if these were both in slope-intercept form, we could easily tell that they were the exact same line. Or if they were both simplified, we could tell that they're the exact same line. But it's when they're in different forms that we can't always tell. Or if it's a multiple, we can't always tell. Like, we don't know right now that this is the same line unless you kind of think about it. So I'm going to multiply this top one by negative 2 so that I have something to eliminate. So I end up with negative 4x minus 2y equals negative 2. And then when I'm ready to eliminate here, I can eliminate this. I can eliminate this. Oh, and I can eliminate this. So I have 0 equals 0, which once again is a true statement. Now, if you looked at this work and I just said, well, 2x plus y equals 1, if I multiply this by a 2, not a negative 2, I end up with 4x plus 2y equals 2. And then I can easily see that those two equations are exactly the same. Sometimes it's not as obvious, and the more practice you get, the more you'll start looking for those patterns. So really quickly before it's your turn, if we are solving systems of equations, we can either look by graphing and see how they are a one solution, no solution, or infinite number of solutions. By substitution, we can look one solution, you obviously will have that one solution, but a no solution will give you a false answer. both substitution and elimination, and an infinite number of solutions will give you a true statement. So I would make sure that you have this written in your notes, that no solution is parallel and gives you a false statement. An infinite number of solutions is the same line and it gives you a true statement. All right, it is now your turn. I'll make this a little bit bigger for you. You have 6 problems that you need to do. In the first part, it says you need to write and graph, so make sure you do both, write and graph a linear system that has no solution, one solution, and an infinite number of solutions. I'm going to ask you to be a little creative with that. Don't be as obvious. Okay, make us think when we're grading this for you. And the second question, it says, how many solutions does each system have? It says to explain algebraically and by graphing. So you'll want to graph these and prove whether it's a one, no solution, or infinite number of solutions, and then also using substitution or elimination, whichever preferred method you like, to prove algebraically that it is a true, a false, or a one solution answer. When you're done with that, make sure that you bring that to your interview with your teacher, and hopefully you can move up a level on your 3.3 standards-based grade.